Let's look at page 600 together. Question 20. The Thomas Jefferson Memorial is located in Washington, D.C. Use the picture of the memorial at the right to decide whether the building is line symmetric. If so, describe where the line of symmetry is. Maybe some of you guys were planning to go to Washington, D.C. for spring break. So this is something that you could have seen, is a memorial to Thomas Jefferson, one of our presidents. So if we look at this image right here, the top and bottom are very different. So if we took a line and chopped it in half this direction horizontally, the top and bottom would look nothing alike. However, if I look to the right and left of it, those sides look almost identical. If I look over here and look over here, these steps are almost identical. So if I took a line vertically and cut it in half, it would be identical, but I would have to do it exactly in the middle. So I'm going to count my columns. 1, 2, 3, 4, 5, 6, 7, 8. So it would go right in the middle of 4 and 5. So 1, 2, 3, 4, 5. Okay, so if I was to draw a line of symmetry, let's see if I can get this. It would have to go directly in the middle of it. See how I got it through the middle point of that triangle, because that triangle can be split in half that way, and that would be a line of symmetry. So if you go directly up and down, that would be a line of symmetry. There are no other lines of symmetry for this building, okay? So where is the line of symmetry? Yes, there is one. And we drew it right there. Okay, a line of symmetry goes on forever and ever, so make sure we draw our arrows. Name the type of triangle outlined in the green on the picture. Okay, so if we look right here on this triangle, that triangle, well, we see that the bottom is a whole lot longer than the sides, right? These two sides are less they're shorter than this long side, okay? Do we think that this side and this side are the same? To me, they look to be the same length, okay? So if I was to draw this triangle, I would put a dash mark right there because those sides look to be the same. Now, if we think about it, equilateral triangles have all sides the same length, so it can't be that one. A scalene triangle has all sides different lengths, and it can't be that one because the two sides are the same. So this is an isosceles triangle. Because it has two sides that are the same length and they have the same angle, okay? Construct arguments. Question number 22. How can you tell when a line is not a line of symmetry? This is an interesting thought because sometimes it's easier to say what is a line of symmetry than what is not a line of symmetry. If we go back up to our building, we knew that this was not a line of symmetry because if we looked at the top half and the bottom half, they looked nothing alike. However, sometimes you can look at a line of symmetry and they can look close, but they're not identical. So if we put our line over here on this side, we drew it through this side of the shape, the sides do look alike, but they are not identically the same. So we know that a line of symmetry is not a line of symmetry when the two sides do not look identical. Okay, so let's just draw a rectangle and draw our line of symmetry right there. Okay, those lines of symmetry are not going, this side does not completely overlap this side. Okay, or if we looked at a different angle, right? If we drew a diagonal angle, that still would not line up. This pointy part would not line up with this pointy part over here. They would kind of like miss each other, okay? So also, so when the two sides do not completely overlap each other, it's also not a line of symmetry, okay? How many lines of symmetry can a parallelogram have? Well, let me draw one for us. Trying to be neat and thorough with my parallelogram. Okay, so here's my parallelogram. It's not perfect, but it'll do. If we took this parallelogram and we cut it up and down, okay, this longer point and this longer point, they would not match up, right? Those 2 points would miss each other. If we took our parallelogram and we cut it in this direction, once again, this long point and this long point, they would flip over top of each other and they would not meet. Okay, there wouldn't be perfect overlapping in this situation. Let's look at a diagonal line. Okay, if we took this and we flipped it up over top of each other like a sandwich again, those points would still not meet each other. They do look very similar, but physically imagining taking this side and pulling it up and over top, that point would end up higher up here than down here with this one. Okay, if we look right here, if we pick this side up and we fold it over, it's not going to create the same shape. Okay, let's use our mirror to help us imagine this. If you look at that shape, that makes like a diamond. It doesn't make a parallelogram. If we look straight up and down, that makes almost like a really wonky trapezoid, not a parallelogram. Okay, if we do this, that makes almost like an arrow, okay, rather than a parallelogram. So how many lines of symmetry do you think a parallelogram have? This is a tricky one because it has 0 lines of symmetry. And I think looking at this image or this shape, you would not think that. But a parallelogram does not have any lines of symmetry. Which figure has 6 lines of symmetry? Draw lines as needed. My first thing looking at A is that none of these sides are the same. This shape is all over the place. Like, this side's different, this side's different. These sides are the same, but nothing would overlap. So I'm going to give it a 0. Oh, maybe that is a line of symmetry. But I don't see any other lines of symmetry. Okay, I take that back. 1. Because those are the same, and that would be a line of symmetry, okay? So there's 1 right there, but it wouldn't work on any other side of that shape, okay? If I draw lines of symmetry on this one, I've got 1 going down the middle right here, 1 going down the middle right here. In between those arrows would make lines of symmetry, but that's only 4. What about here? If I drew a line in between these dots, Okay? This has way more than 6 lines of symmetry, okay? That's got like 8 lines of symmetry. It's got, I think, 7 lines of symmetry. Okay, what about this one? 1, 2, 3, 4, 5, 6. This one has 6 lines of symmetry because if you go from point to point and indent to indent, those are each lines of symmetry, okay? So our answer for this question is going to be 6. Be careful and make sure you count all your lines of symmetry when you're doing this activity, okay? Which figure is not line symmetric? Well, if we look at this heart, you can split it right down the middle. If you go into this like stop sign right in the middle of that red line, you could fold that in half and that would make a line of symmetry. If you take that square and cut right there, you pick this piece up and you could put it directly on top of the other side and that would make a line of symmetry. However, with this one down here, our waves throw us about all over the place. And you can see that whichever way we turn this, it makes new shapes rather than giving us a line of symmetry. So this shape is going to be our no lines of symmetry. Whenever you have wavy shapes, be on the lookout because those are really hard to line up and make symmetric. Okay? There you go. That is our final lesson on symmetry.